Okay, as earlier I accept. I'm starting from the beginning. So what I'm going to do now is I'm going to load two files, S1 and S2, and perform a batch function to find the average. But before that, I will do an artifact scan and same process, what you saw now, to remove these artifacts and later on averaging them and saving that average file. Please note, for those who are new to BESA, please note that .fsg will be the average file of native format of BESA. Let me just go to directly without loading the files. Let me just go to this process batch script. This is where we are going to use the batches. For those of the participants who doesn't know the real, the meaning or else the context in which we explain batch, it is again automation of multiple steps that can be done. So I'm going to batch scripts. First thing what I'm going to do is load two files. Either I can load the files individually or I can load it as a file list. So if I make a file list, first I'm going to show you how to load the file individually. Add file. You can add individually. If you have 10 files, 15, 20 files, 50 files, you can add them individually, or else you can select Control Select or Shift Select, add those files. So in this case, I can add individually S1 and S2, or else I can also use the file list which has been created, load file list, ERP auditory interest, ERP auditory intensity file list. So the file list extension is FLIST, file list. I just load. You can see two files will be loaded. Please do let me know if I'm going too fast or too slow as well. So we have two files, s1.cnt and s2.cnt. They both have 32 number of channels and their sampling rates are same. Now, in some cases, due to wear and tear of the caps or the electrodes, by the time a project is, or else an experiment is started, and after, say, for example, 30 or 40 subjects or patients for that matter, due to wear and tear, some of the electrodes might be broken. In those cases, you might not have the same number of channels in all subjects. This is a common scenario which can be faced. So in those cases, in the further steps, we have certain solutions to face this kind of problems. We will get back to that shortly. So let me just do the batch processing. So now once you load the subject or patient file list, we go to the batch tab here. And here we are going to add certain commands. So in this case, the first process is to load the paradigm which was already created by Harald, as you saw sometime back, explaining that the 60 dB trigger is indeed 60 dB and same. So we can just add command. First, we need to add the paradigm files which are available, or else which needs to be made once. You can go to paradigm section here. So here, basically, when you add commands, there are basically 4 sections, which is main program, where you have all these main functions which can be called. Or else you also have the source analysis module, from which we can call certain functions. The source analysis module, source analysis imaging, time frequency. So these will be covered in detail. I think I have covered already the time frequency analysis. So no, FFT I have covered, but not time frequency. So these will be covered in detail. And these modules can be called into our batches as functions. And in general, we have certain commands which can be used over the left side. You can see that which can be used. So from the main program, I'm going to add paradigm. Oh, for some reason, this is not shown. Oh. Okay. Are you able to see my screen?
Yes.
Okay. 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 So here we can choose the paradigm file where it is located. Just browse to that point. So here it is an auditory paradigm file, AAP intensity, in which we defined the paradigm. Let us save that. So, okay, now the first step would be the program by itself will assign the paradigm, will load the paradigm which we have defined. And next step would be artifact correction. Let us add command for that as again. So you can check for the artifact, correction. So typically when we do this averaging, we don't want to first apply the artifact correction. Instead, we would want to use the artifact coefficients later on at a certain stage. So that makes the data analysis more accurate, instead of using the artifact corrector, because when you apply the artifact correction in the beginning itself, you might distort, as Harald told already, you might distort the signal, which can get average at a later stage. Instead of that, it would make more sense to use the artifact coefficients at a later stage than in the beginning. So we need to ensure, for some reason, if you have already worked on the data and if the artifact correction is already on, you don't want to work on that again. So you need to ensure that the artifact correction is not applied before averaging, or else before artifact scan. So you need to click on that artifact correction view on or off. And ensure that this correction on and view on is off. They are not selected. Next, we would want to use the command for artifact scanning. The same automatic artifact scanning will be processed, but we would want to ensure that for each data set might be different. Some might have very larger, eye blink artifacts, or some of the participants might have, myogenic artifacts more than the others. So we need to visually inspect the artifacts and then, logically take a call on which data set you want to apply more artifact rejection. So here we need to go for this artifact scan process, but we need to wait after the scan. Otherwise, we might directly accept it as it is and then proceed. So instead of that, we might want to wait. We might want to ask the program to wait so that we can intervene and do the manual choosing of the thresholds. Oh, yeah. And press OK. We have added the artifact scanning as well. Next, what we want to do is we want to average the data based on the epochs that were defined in the batch. Add command, average. We can go to this average function. You can use many other features as you see here, which can be automated, which will make you, the life easy when you have a large number of data to be analyzed. So here you need to remove this, use default target. Instead, you need to override target if it is already existing. And here, in order to not mess up with this already existing files, we can put the name hyphen test. And this will use the same base name, depending, say, for example, if you have 10 files saying P1, P2, P3, P4 up to P10, then based on the base file name, it will add and save the averaged file. So now we have S1. So it will take a S1 underscore AV. AV is for average, and hyphen test dot FSG. As I mentioned in the beginning, dot FSG is for the average file. So we can press OK. And we have the batch here. Now, if you want to save this batch for further use, you can either go here and save it by giving a specific name, or you can just continue with this file directly. So for now, I'm just continuing it and pressing an OK. So you know that it will apply the same conditions for this or to this both of these files S1 and S2.cnt. So after the first scan, it is stopping to ask us, how do you want to deal with this kind of artifact? So here I would want to go and make it 80 for the threshold. If you look at the amplitude again, you can see that this has come up to here, the cursor has come up to here, so that we are in the safe zone. And next for the gradient, still there are certain artifacts here. I would want to use 30 as the threshold. And you can see that is also covered, omega. So after applying that, it just continued. And after this, the second file would be analyzed. And here we get again the thresholds. So for here, for the second file, I see that the second file is more, dirtier than the first file because it has more artifacts. So here in this case, I would want to go to 100 and see where it goes. It goes until end of the beginning of this artifact scan. And for the gradient part, I think we can go up to 50 for the gradient part. And we also have a low signal part, which I skipped somehow from the previous step. So when you come to this low signal part, if you have any electrode, drop during the recording, then you will get that low signal artifact. So I press OK. So now artifact scan has been completed. Now it is going to average all of these files by itself, both of these files, not together, individually. You can see this, certain values are accepted, trials are accepted. So it says batch is completed. And here you can use the view log to see what happened during this period. So each step shows you that in this case, 60 decibel case, we have a 68% of the files were accepted, even after doing the artifact correction. So you can see, you can get details about what went and how each step was, processed. You get all details over here. Let's press OK for now and close the batch. Now you don't see anything until I open these two files, S1 average of S1 with the name test. Let me just open that for you. So now you're not seeing this because the extension is of the type .cnt. I change the extension to the BESA format, which is .foc or .fsg. Now you see many files. Let me just check. We did S1 average test, and we can load this file, S1 average test. So here we have 60 decibel data, average 70, 80, up to all. Similarly, we also have the averaged file for the S2 data set. Is there any questions over here? Please do ask. Let me just close this file. Similarly, we also have the second file, S2 average.
Vibhin, sorry to interrupt you because there's two questions at the moment.
Yeah.
So there's this one question: what's the maximum number of files that we can upload in the batch processing?
Mhm.
And to be honest, I don't exactly remember. So in my studies, I've used a really large number of files. Harald, do you have this number in mind?
I think more than 200.
200 at least, yeah.
Yeah,
I'm not sure if
easily.
there is a,
Yes.
is there even a limit? I'm not sure. Huh.
Easily you can load a lot, more than 100. Yeah. 200.
Definitely more than 100, yeah.
Yeah. So just in case if you have more queries, please do get back to us and then we will find some solution.
Yeah, exactly, yeah.
And the second question, Robert?
Yeah, the second question is, of course, again about the batch processing.
Oh yeah,
Whether we
continuous
can
resting.
use it on continuous data and also resting state data if there's no paradigm.
Yeah, I think this depends on what you want to analyze. For example, we have done this. I think we did a webinar on resting state connectivity, for example. That's on the YouTube channel. And for this particular example, we created triggers in fixed spacings. So that's done by ERP. Create, I think it's edit triggers or insert triggers.
Insert triggers.
Yeah, insert triggers. Yeah, and then you can create a paradigm like that. So then you kind of average over the epochs that can make sense for example, connectivity analysis. We also have, we could do an FFT. So yeah, it depends a little bit what you want to analyze, but you don't have to have used paradigms. But if you want to do quantitative analysis, it may make sense to kind of create triggers at regular intervals and then kind of average over these epochs.
Yes,
Yeah,
thank you.
just to add to your answer, Harald, with the batch processing, you can also do only parts of your analysis pipeline. So let's say you want to automatize the pre-processing, meaning with the filtering, artifact correction, and so on. You can write something like a sub batch for that and apply to all your data sets, and then apply some different batches to other parts of your analysis pipeline. So that I found that really useful because you can limit yourself to smaller steps. And then whenever you want to redo a step and adjust the parameters there, you directly have it at hand.
Yes, Robert, I can't agree more with you. Even with my experience, I have had similar experiences where we need to make multiple batches so that first steps covers and then gives you the result, which can be taken and run with the second batch.